how to graph complex numbers using the Argand diagram. Okay, you guys are gonna love this. This is like super easy. Let's just say I have any regular number, kind of like the number 5, and I ask you to graph that on a number line. You're gonna be like, okay, Miss New, I can do that for you. So here you are. You plot a point on the number 5 on the real number line. That's actually really similar to what we're doing with complex numbers, except now not only do we have a real number, but we also have an imaginary number. So there's a real part to complex numbers, and there's an imaginary part to complex numbers. And so what mathematicians did was they said, you know, imaginary numbers are really just like in another dimension. So we're just going to plot these so that our x dimension is our real numbers and our y dimension is our imaginary numbers. And it's really that simple. So let's just say that you have point A. And I just want to graph point A on my graph. Well, I have 2 is my real part. And so I'm just going to go on my real axis and I'm going to go over, okay, 1, 2. And then on my imaginary part, I have 3. So now I'm just going to go up 3 on the imaginary axis. And that's where I'm going to plot my point A. Boom, done. Now you can either plot points in this plane or you can turn them into vectors.
It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
So this thing becomes a vector when I just attach that point to the origin and I put a little arrow on it saying, you know, okay, this is the direction that I'm going, which this is what I'd like you to do for your homework. So let's look at vector, let's do a vector B. A lot of times vectors have this funny little hat. I'm just gonna write that there. It's kind of like an arrow that's missing this other side of it. So again here, you have your real part being -3, and then you have your imaginary part being -4. I'm going to go here, -1, 2, 3. I'm going to go down, -1, 2, 3, 4. And I'm going to make that point there. That is where my vector is going. And this is now become vector B. And it has magnitude and direction. You see which way it's facing, and you can see how long it is as well. If we hadn't have had our snow week, we'd be getting into vectors a little bit, adding them together, looking at them in imaginary land, as well as looking at curves and things and how they graph and how that creates sets of numbers. There is an extension problem. You do not need to do it to get full credit on the homework assignment. And let's just look at 2 more examples that are also in your homework. So here's another example. Like, let's say that I have point C or vector C, right? And they just say 3, and they tell you, like, this is a complex number. We want you to graph this in the complex plane. So this could be rewritten as, I mean, 3 is obviously a real number, right? It doesn't have an I attached to it. So you could say that this is the same thing as 3 plus nothing I. And now you totally see what the real part is and what the imaginary part is. And so I'm just going to go back to my graph and I'm going to go 1, 2, 3. And then I am not going to go in any direction on my imaginary axis. And there's going to be my point C. Or if I want to make it a vector, like I would like you to do, is I would put an arrow on it. There's vector C. I also just realized I do not have my axes labeled. Oh my gosh. And then lastly is this example, let's call this example D, where I just have negative 2i. Pause the video, see if you can graph that. So you got this. This one could be rewritten as 0 minus 2i, and then I wouldn't go in any direction on the real axis, and I would go down to negative 2 on the y-axis. And that would be my point D, or my vector D. There you go, super easy.